Hello everyone, welcome back to Lecture 2 on Engineering Mechanics. I am RAKESH, Assistant Professor in Department of Mechanical Engineering. In the Lecture 1, we discussed about definition of engineering mechanics, classification of engineering mechanics, and also discussed about basic terminologies in engineering mechanics. In this video lecture, I am going to deliver the lecture on laws of mechanics. Okay. The following are the fundamental laws of mechanics. The first one is Newton's first law. Second one, Newton's second law. Third one is Newton's third law. Fourth one is Newton's law of gravitation. Fifth one, law of transmissibility of forces. And the last one is Parallelogram law of forces. Let us brief discussion on these following 6 laws of engineering mechanics. Let us see the first one, Newton's first law. This law is also called law of inertia. Newton's first law of motion is also called as or also known as law of inertia. It states that an object at rest will stay at rest and an object in motion will stay in motion with the same velocity, speed and direction unless acted upon by an unbalanced forces, that means an external net forces. This means an object will maintain its current state of motion unless a force causes it to accelerate, deaccelerate or change direction. For example, let us take one ball on the floor. It stay at rest. When the ball in motion will stay in motion with the same velocity, that means speed and direction, unless acted upon any external forces. This speed or velocity or direction will not be changed. That is called the Newton's first law. Let us see the few examples for Newton's first law. This is a general example. Daily in our life we are seeing this type of examples. A book on a table. A book on a table will stay there unless someone pushes it. The position will not be changed. This is the best example for Newton's first law. See the second live example. A ball rolling on a flat surface will continue rolling unless something stops it, like friction. So these are the two best examples for Newton's first law. Let us see the second law. Newton's second law. It states that the rate of change of movement of a body is directly proportional to the impressed force, and it takes place in the direction of the force acting on it. Here the force is directly proportional to rate of change of movement. Rate of change of movement. Rate of change of movement. Here the movement, we know that movement is the product of mass and velocity. Already we discussed in the previous lecture. Momentum m equal to capital M equal to mass small m into velocity. Here the mass is do not change. So force directly proportional to mass into rate of change of velocity. Rate of change of velocity. We know that rate of change of velocity means acceleration. Rate of change of velocity. So you can write force directly proportional to mass into acceleration. Here A means A equal to rate of change of velocity, that is du by dt. You can observe here, you can also write F equal to ma. That means mass is directly proportional to force, and you can also write F by m equal to a. That means mass is inversely proportional to acceleration. That means when you increase the masses, force will be also increased, but acceleration will be decreased. So this is the regarding Newton's second law. Coming to the third law, that is Newton's third law. It states that for every action there is an equal and opposite reaction is there. For example, consider the two bodies in contact with each other. Let one body apply a force F on another. According to this law, the second body develops a reaction force R, which is equal in magnitude to force F and act. But the line same in the line same F, but in the opposite direction. For example, let us take one ball on the floor. This ball is on the floor. Here this ball shows action F in the downward direction. This ball shows F force in the downward direction. Similarly, this is the floor, develops resultant force in opposite direction. So this floor develops reaction force in upward direction. Here force and reaction forces both are equal but in opposite direction. Let us take one more example. Here ball shows action, floor shows reaction. So action equal to reaction. Let us take one more example, that is ladder. Here I am taking one ladder. Take this is the one ladder. Here the ladder, this ladder is on the wall and the floor. This is the one wall, this is the wall, bottom one is the floor. This ladder having two ends, this is the one end and this is the other end. So this is the first end, this is the second end. This both end show the action towards one is wall and another one is the on floor. This is the F1, this is the F2. Both wall and floor shows reaction on ladder. So this is the R1 and here reaction floor on the the second point R2. Here F1 equal to R1, here F2 equal to R2. Okay, this is the regarding Newton's third law. Newton's third law state that for every action there is an equal and opposite reaction is there. Coming to the fourth law, that is Newton's law of gravitation. Every body attracts the other body. The force of attraction between any two bodies is directly proportional to their masses and inversely proportional to the square of the distance between them. For example, let us take two bodies. Here I am taking two bodies. This is the body mass m1. I am taking one more body on the same floor. This is the m2. Both bodies having forces towards this direction f1 and this is f2. The distance between these two bodies, let us assume this is the distance is d. This is the d. According to this law, the force of attraction between the bodies m1 m2 at a distance d, we can write as F equal to g into m1 into m2 by d square. Here the g means gravitation or constant of proportionality. Constant of proportionality. Proportionality. It is also known as constant of gravitation. Constant of gravitation. Okay, this is the regarding Newton's law of gravitation. Coming to the next law, that is law of transmissibility of forces. According to this law, the state of rest or motion of a rigid body remains unchanged if a force acting on it is replaced by another force of the same magnitude and direction. This replacement of force must act anywhere along the line of action of the original force. Let us take one rigid body. Let us take one rigid body. Let us consider one body. Let F be the force acting on a rigid body at point A. Let us take one point here. This is the A. One force acting here. This is the F1 force acting at a point A. This is the force acting at B. Let F be the force acting on a rigid body at point A. According to the law of transmissibility of force, this force has the same effect on the state of body as the force F applied at point B. This is the regarding law of transmissibility of forces. The last one is parallelogram law of forces. This law states that if two forces acting simultaneously on a body at a point are represented in magnitude and direction by the two adjacent sides of a parallelogram. The resultant is represented in magnitude and direction by the diagonal of the parallelogram, which passes through the point of intersection of two sides representing the forces. Let us take one rigid body. Here the one force. Let us take two forces. This is the F1 force. This is the F2 force. These two forces acted at the same point A with an angle of theta. Let us take F1 equal to 4 units, F2 equal to 3 units. The resultant is acted towards in the diagonal direction. The force F1 4 units, force F2 3 units are acting on a body at a point A. Then to get resultant of these forces, parallelogram ABCD. Now draw the parallelogram diagram. This is the AB. This is the AC. Just draw the parallelogram. AB parallel to this CD and draw the AC parallel to this AD, BD. So resultant is this diagonal. This is the AD, the diagonal. This inclination is theta, and this is the resultant inclination with horizontal force, that is alpha. This is the 4 units. This is the 3 units. So resultant is 5 units. These two forces, parallelogram ABCD, is constructed such that AB is equal to 4 units to linear scale and AC is equal to 3 units. Then according to this law, the diagonal AD represent the resultant in the direction and magnitude. Thus the resultant of force F1 and F2 on the body is equal to units corresponding to the AD in the direction alpha to F1. So this is the regarding parallelogram law of forces in engineering mechanics. Okay, these are the most important. I think this is the sixth parallelogram law of forces. These six laws are very important in in engineering mechanics to solve any type of problems in engineering mechanics. I hope this video lecture is very clear to everyone. In the next video lecture, we are going to discuss about system of forces. That is also very important topic in engineering mechanics. Please don't miss the topic. Thank you for watching. Please do like and subscribe my channel for more updates.